Hello everyone, doing this video from home. Sorry for the bad lighting, but sharing my room with my lizard, Norby, which I'll have to have you meet sometime. Maybe I'll show you a picture before we get out of here. Anyways, time to get on to our volume of a sphere. And on a slideshow on my website, you can actually scroll through there if you want to. I have slides that talk about what a sphere is. And there's some pictures of spheres in the real world, obviously, soccer balls and basketballs and bubbles, and there's a lot of different spheres. I mean, we see them all the time. But what we're doing today is finding the volume of this sphere. So a sphere is it's just a round solid, kind of like the one to the left here, with every point on its surface that's an equal distance from this center. So like if I find the very center of this three-dimensional shape, imagine this was a bubble or something, if I find the middle, it's the same distance to any point on the outside of that bubble. So to find the volume, it's kind of an easy one to remember, but it's kind of a weird fraction. There's two things we can either do. We could either take 4/3 and we multiply that by pi, multiply that by r, which is our radius, to the power of 3. Now, for me personally, I do not like this formula just because it's hard to multiply something by 4/3 unless you take 4 divided by 3 on your calculator first and then multiply by 3.14 and then multiply by r times r times r. So keep that in mind when you are taking your radius, that you have to multiply it by itself 3 times unless you have a scientific calculator and you're taking r to the power of 3. So just keep that in mind when you're doing your volumes today. The one that I kind of like a little bit more, and the one that in our slideshow, if you look up there, I'd rather use is this 4 times pi times r to the third. So that's kind of the same as if I kind of dropped off this 3 and I just did that part. And when I have this divided by 3, that 3 is going to be underneath all of that. So if you think about it, if I take this out, it's still going to be 4/3. That's where that comes from, times pi r cubed. But I like to put the 4 on top of that and then divide everything by 3. That just makes things a little bit easier. So if I am looking at a sphere and I come up with a random number for my radius, so let's say my radius is 24. So I have that number 24 and I can call that 24 centimeters. Oh, even Siri here is trying to find the answer. 24 centimeters. And then what I'm going to do is I'm just going to plug that 24 into my formula because I already know that this is 4, this is 3.14. I know that this is 3. And so really I'm just going to rewrite this with my radius, this halfway across. So I would take 4 times 3.14 times my radius, 24, but I have to multiply that 24 3 times itself because that's what the power of 3 means. And I divide all of that by 3. So on my calculator, I'm going to go ahead and do that. It's a little hard to see in this lighting, but I'll try my best here. So we've got 4 times 3.14 times 24 times 24 times 24, there's 3 of them, equals this big number. It's hard to kind of see, but then I have to divide by 3 and I get this number here. So it's still a pretty big number. So in my volume, I get, looks like 57,876.48. And once again, this is volume, so this is going to be cubic centimeters for that volume. So that's, once again, if I have the radius, I literally just plug the radius in for this r cubed. So I have 24 times 24 times 24. I said the radius 3 times. All right. Now, if I have one that is something like this, where it only gives me the whole distance across, so actually let me pull up this one here. So let's say it gives you the diameter. So the diameter is all the way across. Well, the diameter is, since it's all the way across, the radius is going to be half that amount. So when I'm putting it into my formula, I have to take the 4 multiplied by pi. And then we know that if this is my diameter, half of 18 is going to be 9. So I would have to take 9 times 9 times 9, because once again, this is r to the 3rd power. So 9 times 9 times 9, that's where that comes from. And then I divide by 3. So on my calculator, when I plug it in here, I've got 4 times 3.14 times 9 times 9 times 9 equals that number. And I divide by 3, and we get our answer of 3,000. So write down volume equals 3,052.08. And that would be whatever units. In this case, I had miles, so I would put cubic miles for that volume. So maybe it's a small planet or a moon or something. We're trying to calculate things. So NASA they calculate the volume and try to figure out, how big the diameter is and radius, and that's how they are able to send probes and figure out, different things about the planet. On your worksheet today, the last thing I'm going to show you today is if you have just a simple story problem. So they don't show you a picture, so I'm pretending there's not a picture here. And then all they say is the diameter is 12 feet, what is the volume? So keep in mind that, once again, the radius is half that diameter. So obviously our radius for this problem would be half of that 12. So half of 12 is 6. So 6 feet. So then when I plug it into my formula, once again, I would take 4 times 3.14 times that radius, and I do that 3 times divided by 3, and I figure it out from there. So when you're doing that today, make sure you are showing me the formula you used for all of the problems that you did. So this is why this should take you a while. This is not due until Friday, so just work hard on this, and that way you won't have as much homework tomorrow night, since you're doing it most today. When you do finish today's stuff, make sure you finish that other worksheet with the volume of the prisms and the cones. So on that note, I will say goodbye to you along with Norby. Say goodbye, Norby. He's keeping an eye on you. So farewell, friends. Have a good day, and I'll talk to you soon.